Inequalities in two variables. We've already graphed inequalities with one variable, so the difference isn't just one variable, now you have two variables. It actually goes from one dimension, a number line, into two dimension, your coordinate plane. And I hope when we go through it, we'll be able to see how that relates to the actual answers. But do we have a question?
Why does the homework say page 21?
Sorry, say that again?
Why does the homework say page 21?
Oh, you know what? Yeah, I think I wrote 7th grade on your spot. So that's 7th grade homework. And then I'll change your guys. Oops. All right. Hopefully they didn't get that confused. Oh, that's right. They're good. They didn't have to worry about that. Yeah, let's look at example 1 and let's see how this actually works. So example 1 says from the set, and then they give me 4 ordered pairs. Which ordered pairs are part of the solution set for 4x plus 2y for 4x plus 2y is less than 8? Okay, this is an inequality because it has an inequality sign. So that hopefully clarifies that. And we're going to be able to graph this solution eventually. But all they want me to do is with those 4 ordered pairs in that set, which one of those makes this true? So can somebody give me those 4 ordered pairs again? James, can you give me those 4 ordered pairs?
0, 1, 4, 1.
All right, so they give me these make up my replacement set. So these are my possible answers. All right, on this problem, all we're going to do, well, what do you guys think we should do? Have we done something like this before to see if these fit into this? So what do you think you should do? So someone help me out. What do you think maybe we could try to see which one of those 4 make that a true inequality this time? Because now we're dealing with inequalities. Yep. Yeah, just plug them in. It's really just an evaluation problem. So all I'm going to do is, instead of the x and the y, I'm going to put in these values to replace that. So my first ordered pair, 3 goes in for x, 4 goes in for y, and all you have to do is see, does that make it a true inequality or a false inequality? So here I get 12 plus 8 less than 8. Is that true or false? It's false. So what I want you to do is cross out 3, 4. That is not a solution to that inequality. It is not, because it makes it a false inequality. And basically, we're just going to do this. Oops, we're going to do it 3 more times. So I'm going to put in 0, 1. 0 for x, 1 for y. 4 times 0, 0 plus 2 less than 8. Is that true or false? True. It's true. So what I want you to do with this one is I want you to circle it. It's part of my answer. 0, 1 is a solution because 0, 1 fits into that inequality and makes it true. Okay. Try out the next 2 on your own. See which ones are true and false. Circle the one that is true and cross out the one that is false. So whichever one's false, just put a line through it. The one that's true, circle it. Okay, how many of you got those 2 that are correct and those 2 that are not correct? You crossed out the correct ones, circled the correct ones. Okay, so you see how that problem works? It's really not that bad. You'll have like 2 or 3 of those problems, just like that.
So we have to graph it?
No. This is all you had to do on those problems. But I'm going to go beyond it because I want you to see your answers and how they apply to each other and to the inequality with the 2 variables. Okay, do you guys remember what I just said? With one variable, it's a single line answer. It's just on a number line. When you have two variables, where are you going to put your answers? You're going to put it on a coordinate plane. It goes to two dimensions. Two dimensions, okay? So here what I want us to do is I want us to remember one of the most important forms of graphing, and that's the slope-intercept form. Do you guys remember slope-intercept? Like, do you remember that name? Okay, hopefully you remember the name. We'll get to the details. Slope-intercept. So if you don't, write it down. If you do, write it down. Slope-intercept. You need to know this form. We've looked at point slope. We looked at standard. But slope-intercept, I would say, is the easiest one to graph from. And if you can get it to that, great. Don't do it from standard. And I would not recommend point slope. Yes, sir. Yeah, what is it? Y equals mx plus b. Okay, you gotta memorize that. Y equals mx plus b. Okay, there are two main parts I want you to get. It's the m, which stands for what? Slope. And the b, that stands for what? Y-intercept. Good. So I'm going to abbreviate Y-intercept. You need to know that form. You need to know what each part stands for. And then in just a moment, we're going to look at how it applies to our graphing. Like, what do you do with those numbers? Okay. So we good on that? Okay? Yeah, go ahead.
On the crossing out and circling.
Yeah.
If we did it on our head, you know, similar with that. Yeah. There's so much
To do what?
The first thing we did with the
Yeah.
circling.
No, I get the question. Sorry. I think I know what you're saying, Margot. Be honest. That's between you and the Lord. I don't always know. In fact, I don't know a lot. So you do your best on that. Okay, on this one, what I want us to do is I want us to get this into slope-intercept form. But does anyone notice anything between slope-intercept form and the form or the inequality we have here? There's something that's different that you can't change, and it just makes it weird. Eli? Mm-hmm. Did slope-intercept form have an inequality sign? No. So what I want you to do is this. I want you to picture the inequality sign or think of it as an equal sign. Just deal with it as an equal sign. So can you solve for y on that inequality? Can you solve for y? Okay, go ahead and do it. So what's your first step? Subtract 4x from both sides. You get 2y is less than, and I'm going to put negative 4x plus 8. Negative 4x plus 8. Yes. Are we done here? No, because I still want y by itself. So what do I do now? Or divide by 2. Yeah, and I think that might be the most common thing people do. So here I get my y is less than, and then I get negative 2x plus 4. Two things I want you to get. I hope you guys are able to go from 8 minus 4x to negative 4x plus 8. You should be able to do that pretty quickly. And then the second part I want you to get is when you divide by 2, how in the world did I get negative 2x plus 4? Like, all of it gets divided by 2. So what's negative 4x divided by 2? Negative 2x. What's 8 divided by 2? 4. So that's how I got it. All right. Oh, leave it like this? No, get it into this form completely because we're going to use it to graph. It makes it so much easier. When you go here and you're trying to graph it, you're not using slope-intercept anymore to do it. So yeah, good question. All right, is this in slope-intercept form? Yeah. What's the only thing that's different? It doesn't have an equal sign. It's okay. So what I want you to do is I want you to continue to imagine this is an equal sign, and let's go ahead and graph it.
Didn't we do this last year? Where we shaded the side?
This is not new at all. Well, hopefully, second year's the the charm here.
Yeah, I hope so too.
Yeah, and that usually what happens is when I didn't get something one year, maybe next year I got it, or the year after that, now I get it. And that happened. There's one specific thing I remember as a kid. I've shared this, I think. Their problems were Billy is taller than Susie, and Susie is shorter than Max, and Max is the same height as whatever, and you have to list them in order. I'm like, what? That's like second grade, third grade. I'm like, how do you? And I remember the next year looking at it saying, oh my goodness, that's easy. You just do that. My mind it developed. Yeah, so that happens. Yeah, when you look at this, where do you start your graph? Do you start it with the slope or with the y-intercept? The y-intercept. That's where you start. You start at the positive 4 on the y-axis. So 1, 2, 3, 4, right here. Don't put it on the x-axis, it's on the y-axis. So that's where it belongs. And then what is the slope?
Negative 2 over 1.
Negative 2 over 1. And slope refers to rise over run. So negative 2 goes down 2 over 1 to the right. So down 2 over 1 to the right. Down 2 over 1 to the right. And you can also go up 2, 1 to the left. Up 2, 1 to the left. You can do that as well. All right, and then go ahead and connect it with the line. And it should look something like that. Do you guys get my line? You guys see where I got my y-intercept, then my slope. So far, so good? Now, you've done this graphing, and maybe last time you did the graphing, you're like, oh, I mixed everything up. I didn't even start at the y-intercept. I didn't even know that was a y-intercept. And now you know it? Great. So you picked up something from this. But then you use your slope after. Okay. What I want you to do next, do you guys remember those 4 ordered pairs from that problem we just did? I want you to put those on this coordinate plane. Just put them where they belong. Just put them on this coordinate plane. Put those points where they belong. And I will do the same. Okay. Before we get into that, do you guys have these points here? I try to make them a different color so you can see them better. Okay, do you guys see those points? All right. These 2 points right here, what were they? Were they circled or crossed out? They were circled, and these 2 points, therefore, were crossed out. Okay, these 2 we said were the solution. Why? Because they fit into the equation. But do you guys see anything about this line? These 2 points, listen carefully, these 2 points down here, which we identified as the solutions, are below the line. Which another way of saying below the line is less than the line. And these 2 points are above the line, which another way of saying above is greater than. These 2 are my solutions because they are less than that value. And these are not my solutions because they are greater than that value. So do you see how these 2 points work? And those 2 points would not work? Now, let me bring something else up because there is another aspect I need to bring up. And, oops. Okay, this line is actually a little bit different than when I drew it. It's dashed. Now I say it's dashed. Why? Well, do you guys remember open and closed circles?
Not greater than or equal.
There you go. Open circle means that number is not a part of the solution. Closed circle means that number is a part of the solution, right? Open means there was no equal to sign. Closed means there was an equal to sign. What do you have here? Do you have an equal to sign? No. So what kind of line is that? It's called an open line. It's an open line. If it were a solid line, exactly, because there was an open circle, open line. If it were equal to, it'd be a closed line. Oh, closed line. Okay, maybe not. Anyway, wrestling. Closed line. No one? Okay. I used to watch wrestling too much as a kid. All right.
Don't we shade it down below?
It was always a dream.
In this problem, my answers were down here. Okay, that's it. If I said graph this line I just say graph this line. What you have to do is you have to get that line slope-intercept form, which you guys did. It would be a dashed line because it's not equal to, and then I would have to include how many points. Well, how many points are less than that negative 2x plus 4? How many do you think?
A billion, trillion, infinite.
There you go, infinite. So this is what I would do. I would graph all of them.
Several infinite.
I'm still going. Still going.
Yes. You still got billion. You still miss an infinite.
That was round one,
I'm
guys.
getting a few infinite of the infinite. You made it worse.
All right, this is what you do. To show it, you don't have to prove it, but just to show it, just shade that line. To show that you're demonstrating all these points. Good question. I'll get to that. That's a good question. All right. How many points are represented now in the shaded? What am I trying to demonstrate? That it's all these points, right? Which is how many? Infinite. Okay, listen to me very carefully. I think this is not only practical, what you're going to actually do, but it's also like, whoa. Okay, how many points are represented on a coordinate plane? Infinite number. You have an infinite number. And this coordinate plane goes infinitely all directions. And we don't have to draw it all to show it all. So here I just showed all of them. And then I'm talking about this side right here. Okay, when I drew this line right here, I split this coordinate plane into two, right? This is what we actually did, which I think, okay, I don't understand infinity still. Like, I still think about it, I'm like, because I still picture a really big number, and then plus that, wait, no, that's, okay. So I struggle with infinity, but I can split infinity in half. Isn't this half of infinity?
Yes.
And that's another half of infinity?
Yeah, but
So I split,
still infinity.
it's still infinity, right? So I split infinity into two parts,
Still just infinity.
which is infinity. Yeah. But you can manage it. You use it. It is very weird. Now, listen to me carefully. Your homework is going to be take this line and graph it. And the way to graph any inequality with two variables, right, 1, 2, is you've got to have a shaded part. So if you just gave me a line, whether solid or dashed, but no shaded part, that's not the answer. Because you have to show me all the points that are involved, which in this case is anything below that line. Okay, no, this is not set builder, thankfully. It is, and it really is, you can say, why is any number such that y is less than negative 2x plus 4? You can say that. Yep. All right, I had a good question. Mr. A, what if I have a vertical line? And what if I'm saying x is greater than, let's just call this 4 right here. So what part would you shade if x is greater than 4? Yeah, what points are greater than 4? It's anything to the right. Greater than is to the right. Less than would be to the left. Okay, so that makes sense on the x-axis. And then, I hope you guys are okay with this one. If y equals negative 5, below it would be less than, above it would be greater than. So that's not too bad. Okay, let's look at another example and see if we can get it. Example number 2. So this is like the main part of your homework, which hopefully you'll be able to do. Y plus 2x is less than, actually I'm not going to use black, it didn't show up. Example 2. Y plus 2x is less than or equal to 3. Okay. Did they give me a replacement set? Did they give me a set of ordered pairs to check out? Nope. They want me to tell them what infinite set of numbers are going to fit this inequality. So my first step is to write it in slope-intercept form. Okay, is this in slope-intercept form? Nope. So what do I do to get it there? Solve for y. Get y by itself. Subtract 2x from both sides. I get y is less than or equal to, and I'm going to put negative 2x plus 3. Again, you should be able to go from 3 minus 2x to negative 2x plus 3. You should be able to go from that. And if you don't, ask me, because I'll help you out. Slope-intercept form? Are we there?
Yes.
Okay, so it's time to graph it. So here, 1. Okay, where do I start this graph? If it's in slope-intercept form, where should I start it? Positive 3 on the y-axis. Y-intercept, y-axis. 1, 2, 3. Okay, I have my point right here at positive 3. By the way, if you want graph paper, you can use it. But I think you guys should be able to do it on your normal paper if you're careful. Just be careful. Don't go too fast. Don't try to rush through it because then it makes it sloppy and hard to read for you and for us. I got my point on positive 3. Where's my next point go? Or where does another point go? Pick another point. Where does it go? What's my slope? Down 2 over 1. So I go down 2 over 1, which is right here. Or I can go, if I want to go to the left, I could go up 2 over 1 to the left, up 2 over. Okay, what kind of line should connect those points? An open or closed? Closed, which is just that. It's just a solid line. And then what part gets shaded? Why the left? I mean, the right looks just as good. Less than. What points would be below the line? Well, if this line kept going, below the line would be this region right here. So it's this shaded region here. If you're struggling with like, Mr., how do you know that's above and how do you know that's below? All I do is I usually pick 0, 0. Should this be a part of my solution if I graphed it right? It should be, right? 0, 0 right there. So is 0, 0 fit in here? Well, let's see. What's 0 plus 0?
0.
Is that less than or equal to 3? Yes. So 0 does fit. 0, 0 does fit. Okay, you can test it whether it's in the region shaded or not. That is a part of the solution. So that's your graph. All right, remember how I called it you're splitting infinity into half? Okay, so this is half of infinity, and this is another half of infinity, and this line separates the two. So we call this a half plane, and we call that a half plane. What's the whole thing called? Do you guys remember? It's a coordinate plane. So you get how I say half plane, half plane? And they're equal halves, by the way. Even though, how's that? They're equal halves. You have an equal amount here as you do there, even though you don't know how much either side has. Yeah, and the thing is, that seems so weird to me because I'm like, are you sure? It seems like there's more over here than over there, but it's not. They go infinitely out there. Okay. You guys good with that? Yeah, it blows my mind too. And it is really cool because it's a concept that we all, like if I say infinity, you all start thinking something if you're listening. And you start thinking about it and you're like, yeah, I don't get it, sorry, I'm done with that. Or like you sit there and think for a while and like, oh man, you struggle with it. Okay, your homework tonight.
Oh wait, we gotta ask you. Do you think it's gonna snow?
Oh, yeah.
Bye, Swivl. This is off the record.